Okay, it's 3:05. Time to get started. My name's Curtis Poe, better known to many of you folks as Ovid. I'm sure a lot of you folks already are familiar with who I am, a little bit about my background. I do want to apologize in advance for this talk. Some of the concepts in here tweak people's minds just a little bit. It's not as complicated as the stuff that, say, Damien or Jonathan sometimes puts out there, but at the same token, it's also not quite as funny. So I apologize in advance. It's a fair trade-off, I think. So this talk is not going to be a tutorial. It's not about how to use roles, because it turns out roles are really, really easy to use. Instead, I'm going to be talking about what's happening under the hood. Not under the hood, but what's happening design-wise, the problems that roles are designed to solve, and why inheritance doesn't quite do that, and I'll be looking at a few similar things. But first, I want to go back to the past and talk about Simula 1967. It's released in the summer of love, actually, when I was born. Yes, I'm old. And Simula 67 was the first modern OO programming language that we had out there. It had classes, polymorphism, encapsulation, and inheritance. And the first three of those ideas are, they're more or less non-controversial in the world of OO, but inheritance. For going on 5 decades now, we've been arguing about how to do inheritance correctly. And that's something really interesting to think about. And many languages, they offer multiple inheritance, where you can inherit from 2 or more parents at the same time. And one thing I find absolutely fascinating when I was originally writing this talk and doing research into it, the languages which offer multiple inheritance, Perl, C++, etc., as a general rule, style guides say, you can have multiple inheritance, do not use it. Just, no, we don't want you to touch that. It's a bad thing. If you know what you're doing, fine, go ahead, but really, you don't want to use it. In fact, it is so bad that many languages do not allow multiple inheritance. Of the languages that don't allow multiple inheritance, almost every single one offers an alternative to multiple inheritance, and furthermore says, go ahead and use it as much as you want to. It is so much better. That's not always true, as you're going to see as we go further along. But inheritance is such a complicated thing. It seems simple, but it has so many subtleties that we've started to develop strategies to understand how to cope with inheritance better. I'm not really going to go into these too much, but we have the Liskov substitution principle. We have something called strict equivalence. Not too many people have heard about it, but it's important. We have C3, which I personally find to be about as useful as an ice pick on the Titanic, but I won't go into that too much. And then we have the alternatives to inheritance that we often deal with, interfaces, mixins, delegation, each of which has their particular uses. But again, it's our struggling to deal with a fundamental issue in OO programming that we've been swinging at and failing for almost 5 decades now. So in reality, it's about 4.5 decades of pain. That should tell you something. Classes, polymorphism, encapsulation, we don't have an issue with this, but inheritance, this is a code smell baked into the core of the language that you are using right now. This isn't a code smell and something you hacked together last week. So as a code smell, it's worth looking at it a little closer and find out if there really is a problem here. So I'm going to make you hurt just a little bit. You're looking at the B object hierarchy for Perl. If you're not familiar with this, this is the pure Perl front end, which more or less represents what the Perl internals look like. It's not entirely accurate, but it's close enough. Let's take a closer look at part of this. We can see all these funny little classes right here, and this looks rather interesting because if I zoom in, that's actually multiple inheritance we have there. So I want to explain this for just a second so you understand what's going on. Most of you are familiar with the idea that a Perl scalar can represent a float, an integer, a string, and other things. So in this case, the class at the top, SV is a scalar value. IV on the right is an integer value. PV is a string value. That P stands for pointer. You can think of strings in C, pointer to an array of characters. And then down at the bottom, we have a PV IV. This is the case when you have a scalar which has an internal integer representation and a string representation. And why would you want to do that? So this is pseudocode of what it could look like. If any of you are familiar with dual vars, it allows you to twiddle those interesting internal representations so they don't always point to exactly the same thing. And why would you want a different string value from the integer value? Because, well, On the string side, 3, the ASCII value is 51. You wouldn't want to use that in your mathematics because that would throw everything off. So you keep all of those nice and separate. And again, this isn't really what these internals look like. But here's what it lets you do. So in Perl, and Java allows something very similar. This is so important that Java, their one exception to operator overloading is to allow this one feature that's built into Perl. My count equals 3, count plus equals 2, so we know count equals 5. And down here we say I have count apples. And again, Java, same thing. This is so incredibly useful. But internally, you have the numeric and the string representation. So if you're familiar with open, my file handle, mode, file name, or die $bang. $bang is actually a dual variable, which has an integer value representing the error code, and a string value, which is the human readable version of that error code. It's very common in Perl. So again, pseudocode at the top in our string package, the PV, as string might return the string value, PV. IV, the integer value, as string, might return the integer value. And our package, bpviv, it actually inherits from the string version first and then the integer version first. So if you want to print it as string, you're only going to get the string value. You cannot get the integer value out of that. That's a side effect of diamond inheritance. So now you have to hard code the integer value class name into the method name in order to get that integer value. So we call an encapsulation violation. You don't want to know about your inheritance hierarchy. Now, just as an aside, when I first gave this talk, someone asked me, can you pick a simpler example? And I started thinking about this, and I'm like, no. Because the reality is, when multiple inheritance works, it's fine, it's easy, not a problem. When it doesn't work, this is what happens. It becomes complicated, a little bit harder to think about. And the reality is systems grow. If we get to the point where we start relying on multiple inheritance too many times, these sorts of problems crop up more often. They're subtle, they're difficult. And what's going on, the reason why we have these complications with multiple inheritance, or sometimes even single inheritance, is because there are two things that classes are trying to do. And it's always been two things that classes have been trying to do. One, a class is an agent of responsibility. If there's one thing you want to think about for an object, it is an expert in what it is supposed to do. And as your system gets bigger and as your business rules grow more complicated, now this item object needs to maybe have a wait method available to it. Maybe it needs to have an availability method. All sorts of things get added to objects as our responsibilities increase. This makes the code larger. But if you reuse something, like when you use listutil, do you import all the functions from listutil? No, you just import the ones you want. So if you're using inheritance with an object, a lot of times you're doing that just because you want one or two of the behavior inheritance with a class. You just want one or two of the behaviors from that class. You don't necessarily want the entire thing. So for code reuse, you just want to reuse the code you actually want to reuse. Not all of it, just a small amount. So class responsibility wants larger classes. Code reuse wants a smaller set of code. You have a fundamental tension in the underlying design that inheritance implies. And the solution is to decouple these two things. And this is where it starts to get interesting. So we start looking at the field. Is everyone with me so far? You've got a rough idea of what we're talking about? Okay, good. So Java is, I find this so amusing because what they've done for this is they've created interfaces. If you're not familiar with Java, an interface is something that you implement. And it's just a list of method signatures. I'm going to implement this method, that method, the other method. In other words, this is something your class is responsible for. So Java has successfully decoupled class responsibility from class responsibility. Well, that's curious. What about code reuse? Well, I'm sorry, you can't provide an implementation with interfaces. So C# is actually going to do that. Java might be doing this in the future. They're trying to work on solving this issue. But basically, they completely failed to separate the class responsibility and the code reuse. Delegation is another thing which is often extremely appropriate, but that also has its own problems. Quite often I find myself when I'm using a system which abuses delegation, they've created small classes simply to have something to delegate to, not because those things deserve to be classes, and those are usually abstract behavior that other classes want to share. And then we have mixins. We also have aspects, but I didn't have the time to cover their failure modes. They're amusing. By the way, traits or roles were partially in response to the problems that aspects have. So look up aspect-oriented programming at some point. Mixins. A lot of people love the idea of mixins. So we're going to take a little look at them really quickly. Mixins did not originate with Ruby. Mixins originated with a variant of Lisp called flavors. The gentleman who wrote it, he was going down to his local ice cream shop, and they would give him ice cream of a particular flavor, and then they would mix in another flavor. Made it a little more interesting, and he liked the idea. So he built this into the flavors OO system for Lisp. And eventually this worked its way into Ruby, and a lot of people liked it. So let's imagine, we're going to describe this real quickly so you can understand what's going on. Imagine you're writing a game. You need a practical joke. Your character walks into a room, a fuse gets set, and then the thing explodes. It's a practical joke that the character encounters. Now, what happens is you don't want the fuse to have a random timing. It has to go off at a particular time, but you don't want the explosion to kill the person because it's a joke. So you have two classes, your bomb class and your boss class, and you know you have similar behavior in each of those classes, and you're a good programmer, so you want to reuse this behavior. So if you look up here, you see your bomb fuse, it's deterministic. It goes off after a particular time. You can't control your boss fuse, so that's obviously not good. Your bomb explode, that kills you. Your boss explodes, sometimes you wish it kills you, but that's really the method you want because it doesn't actually kill you. So we want the bomb fuse method and the boss explode method from those other packages. Are you with me so far? So let's see how this is implemented in Ruby. On the left, we have the bomb mixin. On the right, we have the boss mixin. We have def explode, def fuse for both of those. And the bomb side says bomb explode, bomb fuse. And the boss side puts the string boss explode, boss fuse. Fairly straightforward. And here's your practical joke class. You include boss, you include bomb. You instantiate a new practical joke object. You light your fuse, it explodes. And it says bomb fuse, bomb explode. You didn't get the boss behavior. Why is this? So in Ruby, if you ancestors is the method which will give you your inheritance tree, and you'll see practical joke inherits from boss, inherits from bomb, inherits from object, inherits from kernel. They actually implemented mixins via a single inheritance chain. So with multiple inheritance, what usually happens is the first method you encounter wins, the first class you've inherited from wins. With mixins, the last one you inherited from wins, and any mixins which have a similarly named method, sorry, you don't get them. Sort of. This is where it gets even more complicated. On Ruby mailing lists, every once in a while, you'll encounter someone complaining about a bug where they say, yeah, I wrote this mixin and it called super, but I didn't get my parents' super method. I got this other mixin method. Well, first of all, mixins shouldn't be calling super because they don't know what they're going to be mixed into. And this is just a problem with how inheritance is working if you try and abuse the system. So mixins don't do what we want. So let's look at roles. Left side, we've got the bomb role. On the right side, we have the boss role. This code is virtually identical, except it's in superior language. Just kidding. And we have our practical joke package, use moose with bomb boss, joke, practical joke new, joke fuse, joke explode, and due to a method name conflict enrolls bomb and boss, blah, 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 blah. It doesn't run. It doesn't know which bomb and boss methods you want. And that's very, very interesting because now, with either multiple inheritance or mixins, this would have been difficult. But now you don't have to worry about it because it's not even going to compile. So instead, with our bomb, we exclude the explode method because we don't want to kill anyone. With our boss, we exclude the fuse method because we'd like to know when it's going to blow up. And then we run the code, and down at the bottom, you see we have bomb, fuse, and boss explode exactly the behavior that we wanted. Fine-grained control of picking out the bits that we want so the person composing this class gets exactly what they want, and the issues you have with inheritance go away. You don't lose that behavior if you don't want to. You can alias the method to something else and still call your original method that you moved away to avoid the conflict. But it makes your life very simple, lots of control. And just to show you how easy it is generally to implement something like this, you can also, so here's a class, my object. It does the as YAML role, and it provides a to hash method. And you see on the right side, you've got the role, does as YAML, and it requires a two-hash method, so a role can say, I require these methods in order to run properly. And then you can see in the toYAML method, we actually call the toHash method and we dump it out. So you can now serialize any object that you want to as YAML as long as it provides an appropriate toHash method. This is how behavior, which might get shared across multiple classes, which are unrelated by inheritance, can easily be distributed. It's very simple. Obviously, there's a lot of caveats with this, particularly since in Perl 5 we don't have method signatures. This does limit the utility. But we can see that lots of languages are really appreciating this. It's been adopted all over the place, but I won't go into that list. So I want to talk about a real-world problem, just to show you that this actually does work. I worked for the BBC for a number of years, as many of you folks know, and we were the world's largest broadcaster. So at the time, this has grown considerably. We were representing in something called the PIP system, the metadata about what TV shows were available. So people all around the BBC, their systems could call into our system and find out what's the schedule for this channel, what's the schedule for this show. And brands are things like Firefly, Battlestar Galactica, or just the name of a TV show. The series, for you in the American audience, that's what we call the season. Then we had episodes. You've never seen an episode of a show, ever. Instead, they have versions, like the version might be edited for adult content or something like that. You've never seen a version either. Instead, you may have seen a broadcast on the television. You may have seen an on-demand on Sky or Hulu or something like that. And on top of that, even though this looks kind of top-down tree-ish, it started to get really gnarly. You had series which could have sub-series, and then sub-series which could further have sub-series, and all sorts of constraints on them. The problem domain itself looks simple. It got very complicated and hairy. And right now we're just going to look at how a television program might have been modeled in this system. This is, a lot of the stuff here is condensed down. This isn't exactly what we had, but it's close enough to actually be accurate. My apologies. So you had a television program, and it would inherit from tagged, which would inherit from audited, which inherited from our custom result source class, which inherited from DBX class result source. Now, some of you really familiar with programming are looking at this saying, why is tagged and audited actually a class? Without going into too much detail, the primary defense that most of the developers who had built the system before me would have said is, it worked. And they would inherit from things like this, and it made their life fairly simple in some ways. But as the system grew, it started to become more unmaintainable. So again, BBC, world's largest broadcaster, of course they had a table listing all the countries, and this inherited from something, a static result source class. Because we weren't updating this information too often. We could, but it had a few other behaviors in there. But it was all still nice, simple, clean, single inheritance. And then the Berlin Wall fell, and new countries started popping up like popcorn. The BBC is very, very important. If they accidentally misname the new Czech Republic as the Ukraine or something like this, this could cause an international incident. We needed to know who was actually changing information in the country table. So we wanted to audit this information. But we can't actually audit this information when it gets changed this way, because now everything that inherits from that static table is audited. We didn't want that. There's a number of ways we could have flipped this around, but eventually we fell back onto this. Country, multiply inherited, from audited to my result source static. And that turned out to be a problem because the audited class offered a whole bunch of behavior that we didn't want for the country class, but it worked. And eventually you as a developer might go to your project manager and say, this is getting to be complicated and hairy, and why did I, can you give me some advice? And she might look at your code and say, why in the heck are tagged and audited classes? And then you kind of sink because she's right. And at the end of the day, you wind up rewriting the entire system when all you wanted to do was add a single line to a log file when someone changed the country. You wanted a tiny bit of behavior added to country. You didn't want to faff about with your inheritance hierarchy. You didn't want to refactor your entire system. You didn't want to struggle with multiple inheritances. You just wanted to add that one tiny bit of behavior. And that's what roles do. So this is what the system would look like in a roles model. The only reason you would inherit from the result source class is because DBX class requires you to inherit from it for its implementation. In fact, if it weren't for that, I would not have had any inheritance in the system whatsoever. So your country class might have looked like this. Package country use moose extends the my result source with two roles, does static and does auditing. So you can see pretty quickly up there what behaviors it actually implements, and you minimize the inheritance, and it makes it easier to understand. So this hierarchy was actually fairly simple on this portion of our program. You'll notice there's no, without caring about what the names are, there's no multiple inheritance in that, but it was still getting to be a little bit annoying, and afterwards it was completely flat. Everything just inherited from one class. And if you opened up something, so can anyone here maybe figure out what sort of behaviors this episode class might have implemented? So you can, yes, and it's pretty simple to figure out what those various things are. I can search for episodes by their broadcasts or by tags. We can possibly guess what tags are. I can search for them by title, by something called promotion. I don't know what promotion is, but I could probably learn it pretty quickly. I can probably make a guess as to what a universal identifier or an identifier universal is. So what we have is an incredibly complex class. There's actually a lot of code below this. You open it up, and at the top, you get a convenient list of all the behaviors that this class implements. A brand new programmer, day one, can open this up and have a pretty clear idea of a lot of what's going on underneath the hood. So in short, what roles offer you is they make your code easier to understand. They simplify it a lot. I had this happen in lots of systems. By the way, I want to mention, I found out in Perl 6, if you open up their class how in their meta model, they don't have inheritance there. They have a huge list of roles just at the top, implementing something just like this. So when you read through the code, it says it does this role, it does that role, it does the other role, and it's very simple and it's very clear. And more people are going with this, and they're actually using roles with more of a tinker toy approach of assembling objects with the required behavior, as opposed to using any inheritance. And today, I quite often write fairly complicated systems, and I have no inheritance whatsoever. And it makes them very easy to understand and to refactor as needed. So it makes your code easier to understand when you switch to roles, because you're separating out the individual behaviors that you want from the class responsibility that you need to present. Your code winds up being simpler, your individual classes are smaller, you have shallower inheritance trees, so you don't have to dig through there to figure out the behavior you want. And your code also happens to be safer. If a role requires some methods and those methods are not there, it will fail at composition time, but that's close enough to compile time to ensure that you don't get a call at 2:30 in the morning saying that this 5-hour batch job just failed with a missing method. You find out immediately that you're missing those methods. So that's a little bit of the benefit we get from a more static system built into our very dynamic system. So we kind of get a little bit of the love from both worlds there. It's very nice. So my wife told me to put in this slide. My apologies. Any questions?
Would you take a step further, and would you agree that composition is a little safer than Mixins, but maybe a little bit more verbose to use? Because with Moose, we have these ability to automatically delegate. It's not that much more work in some cases.
Are you referring to specifically composition via delegation? Is that specifically what you're referring to in that case? I didn't really go into this too in depth. Composition via delegation. So delegation, by the way, you have an object. You instantiate an object, and it has an instance of another object, and the first object's methods will automatically delegate off to the methods in the other object. Sometimes this requires a fair amount of scaffolding depending upon the programming language that you're working with, the tools that you have available. Sometimes you want bidirectional communication between the two because they wind up being tightly coupled. My concern is the object you're delegating off to quite often winds up being something which should not be an object, but it's simply there because you need to have another class to hold this behavior. So I see the auditing classes I see in systems where what is an auditing? There isn't an auditing. Auditing is something you do. It's some behaviors that you have. But we often have auditing or security classes, which are kind of abstract things, not concrete things. So this is another concern. Plus, in Perl in particular, I see delegation as being, whenever I benchmark it, it's quite a bit slower. So any system which forces you to rely on delegation, you wind up taking a performance hit, though obviously that's not my first consideration. So those are the things that I think of when someone talks to me about delegation. Mixins, I just say no, because they do solve some of the problem. They properly separate the behavior from responsibility, but you have the same ordering issues and you don't have control over it. For a large system, it's problematic.
I probably misspoke. Should I not use the term mixin for a role used with some implementation?
Oh, no. Mixins and roles, totally different. Totally different. I apologize. I must have misunderstood that.
But there's a duality, right? A role can be kind of like a Java interface, or it can have some implementation with it.
That is correct. So, could you restate your question then? I rambled on too long and I forgot what you were saying.
Pure virtual interface type thing where you just list the required methods.
I love doing that with roles. If I want to guarantee that this particular class implements something, I do this with factories quite a bit. So that's when I use that. But I'm not sure exactly what your question is then.
Be afraid of when using roles that come with some implementation.
No, I don't think there's any problem with that. With the caveat that, again, we don't have method signatures. As a general rule for systems, if you have two methods with an identical name, if they're doing semantically different things, there's a problem there. They want to do something which is more or less identical, but because we don't have method signatures, it's a little bit harder to guarantee this, so we lose some safety there. But ask me again later and we can talk about this more in depth. I've got another question back here.
Do roles support aliasing in any way?
Can you please define what you mean by aliasing? Because I can say yes and no.
For example, in the case where you have two roles that are identically named in terms of their actual sub, in theory, it's possible for various API methods where you have a class that needs to be, I should say, a role that needs to be executed for one API and a similar role for another API. In those cases, is there any way to alias those roles so that the names do not conflict?
Do you mean the package names or the method names?
Well, the package names obviously would be different, but how would you reference them exclusively?
You mean the method names like that?
Okay, well that's the exclusion. I think he wants to still be able to call both. That's the alias.
Yes, that's the alias, the red part. Yeah, so it's there. There is a caveat to keep in mind, and it's one of the problems that I know traits researchers and others have been struggling to deal with. If you have languages with extreme late binding, such as I don't know, Perl, for example, what happens when you alias fuse to random fuse, and internally the boss role wants to call its fuse method for some reason? Then which fuse method does it get? So for some languages, you could bind that at compile time to guarantee that boss would still call the correct fuse method. But in this case, it's going to be delayed, and it's actually going to get the bomb fuse method. So be very careful about aliasing. Excluding an aliasing methods, you should consider it to be a code smell. It is not a bad thing necessarily, but it is certainly something you should look at, and it is going to cause you problems if you over-rely on it. I tend to use this as a stopgap measure when I am refactoring a system, and I find similarly named methods when I'm turning classes into roles. But because of some of the issues with the timing of when methods get bound, you can get a method that you did not expect. So you want to avoid that if you possibly can. Does that answer your question?
Yeah.
Okay. Yes?
In browsing CPAN, I see a lot of inconsistent naming conventions for roles.
Yes.
Any suggestions on best practices for how to name them?
Your guess is as good as mine at this point. I have gone back and forth a few times trying to figure out what the best thing is. I've often liked things does with a gerund, like does targeting does blah, 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 but that doesn't always work, particularly when you call object arrow does blah, blah, blah. You wind up getting something repetitive there. I'm not sure what the best thing to do is, so I wish I had a better answer. I wish you had not asked that question. But at least I'm honest. Yes?
Have you run into situations where inheritance does make more sense than using roles? And what types of things would those be?
So the question was, have you run into times when inheritance does make more sense than roles, and what would those situations be? I will say inheritance does make more sense with roles when you have a pre-existing system where the inheritance is already placed, and that is the mechanism for using that system. I would not suggest refactoring the system just because you feel more comfortable with roles. DBX class is a great example. I've often thought it might be interesting to try and write something which would, encapsulate that and turn it into a role or do some fancy delegation, but no, inheritance is how it's designed to work. Some people would argue that an abstract base class, you have a vehicle and you have a car subclass and a truck subclass or whatever. Some people really like that style. I don't. I put that into a role for the same reason that I would put a person object into a role, even though I might have a subclass of employee and a subclass of manager or whatever. Simply because you have various things where you don't necessarily know how they might be shared across different objects. And I really like the ability to assemble things as Tinker Toys and say, this is the responsibilities I need, put together all of these components, et voila, it works. But it's kind of a radical view. I know there are a few people going out there and building systems like this, and they like that, where they use no inheritance. I think I'm in the minority with that. So take me with a grain of salt.
I've got an answer to that. Relates to my lightning talk later. If the code you're interacting with is already checking that some object you're passing in is some class, you may have no choice.
Yes, he's got a good point. Attributes in, say, Moose, when they say is a date time, and you want to pass in something that's not a date time, you had better pass in something that inherits from date time. And good luck on that. Yes, we got a few minutes left. Yes?
How do roles work in Moo? Are they comparable? Or?
Roles in Moo, there's a few issues with roles in Moo. For philosophical reasons, they've decided to, I believe, remove the alias and excludes. They don't particularly feel comfortable with them. Also, I've submitted some bugs for roles in Moo because when I've tried to use Moo in production systems, I wound up with ordering issues with how I consume Moo roles. And I'd have to look at my bugs to remember exactly what they are, but they're actually pretty hard things to resolve. So I think Moo's great, but I don't feel entirely comfortable with how its roles have actually been implemented. So go look at the bug queue for Moo, and that'll give you some ideas of what's going on there.
What about with Moo's MOOS?
I have not. There's another one? Yes, what about Moose, M-O-O-S? Can you have Unicode letters in the package names? I don't know that one, but I'm waiting for the infinity symbol in Moose. And any other questions? I think that's it. Thank you very much, folks. That's perfect timing.